Hello. Okay, we're live, and we are no longer dropping frames. So I think we just were on a bad restream server. Hi. I've been trying to figure that out. It's been doing that every so often. Hopefully now stream should be nice and stable because everything else on my end is a-okay. So we did this yesterday. This was pretty cool. 80 mil steps of breakout at 2.7 mil steps per second. 29-second solve. And this is 80 million frames with no frame skip. So, I mean, arguably this isn't even really sample inefficient at all either. So here's the plan for today. It's currently 8:34. We're going to put in about a 2-hour morning session here. Maybe 2.5, we'll see. And the main thing I want to do is just see with all the improvements we've made to Puffer, whether we can get away with way faster training settings. So the idea here is that there are settings you can apply that are faster in wall clock time, but they may or may not train stably. That depends on your algorithm. So now with muon and with advantage filtering and puffer advantage and all the things that we've done over the last month, can we actually bring puffer to the point where we are no longer training at 1,000,000 steps per second? We're training at multiple millions of steps per second. There is one thing I want to test just for ha-has before we really start on this. And yeah, let's do one other thing just for ha-has here. I think we might have to change the optimal, the learning rate for this. So I'll do like 2 experiments. Uh-oh. Ah, right. I forgot I broke non-recurrent policies. All right. We'll do that later then. Let me go grab the original breakout params, and I think we're gonna actually be able to set this up as a proper experiment, like with like actual clean comparisons before and after with all the new organizational stuff I set up. Do start the repo. Helps us out a lot. Okay, so before we had all these parameters. We're just going to take these, and we are going to use these on breakout for the before. And I'm going to set this up as Neptune, and this is going to be slow baseline. Tag. We're going to do this for all the M's. Go grab our Neptune. This is the neural MMO run from last night as well. This is 30 billion, and we're at 4.7. Actually, let me check real quick if that's any good. Is this the new one here? Yeah, it is this one here. So this one is perfectly on par so far, it looks like, with the other ones. And hopefully it stays that way. Let's get our key. I have a lot of things I want to try on Neural MMO in the next several days. One of the things I've never been great at as a researcher is scheduling experiments so that I always have something, the next idea running. It's been very difficult to align my thinking about a specific topic to the amount of time jobs will take. But we're still making good progress on that one. Okay, so why is breakout slow? That makes no sense, right? Puffer breakout. Is something wrong with this config? I am confused. Let me just take Neptune off. Yeah, so this is fast, right? $32K mini batch. 4096 M's. Do you see anything that would mess up the speed? No, this was fast before as well. This is gonna be some weird compile bug. How do we regenerate kernel? How do we regenerate the kernel? I'm trying to think. Actually, here, let's try this. Let me make sure there's nothing else I could possibly have messed up here. I don't see anything. The fact that it's 63, yeah, it's all in training as well, would suggest the optimizer is screwy somehow, right? Where is... Definitely has an LSTM in there. So, that's bizarre. Oh, update epoch 64. How did this happen? Yeah, how did this happen? That's really weird. Well, whatever. Let me... at least it's not something crazy cursed. Okay, so we'll get our slow baseline. It's a little more sample efficient on the original. And then we'll do fast baseline. I will get an additional tab. So not a perfect solve in, oh no. I mean, that's pretty darn close. This is 60, was this, no, 80 mil. And then here, this one is 80 mil. So no, see, this one is flatlined up here way before. So hang on, let me, should be higher. Or should it just be more steps? We could add a very small, we could go up to 100 mil. And then this should still be way faster, right? Or do we think not? So we get the 29 seconds. These are both about 29 seconds. That's interesting. So then, I mean, this is not properly tuned, though. Can we get this one to be almost as sample efficient, right? Let's see. So default's 0.025. So we would like to do 0.1, which is this crazy high learning rate. Since we 4x'd the mini batch size. Did we double the number of environments as well? believe we did. Okay, so this is not stable. Yeah, this is not stable. Should it be linear increase? Or should it be square root? I think it is linear increase. So here, so it's slightly less sample efficient, it seems, because we can't quite support the linear increase to learning rate. Not quite. We do it this way. Oh, now this is failing too. Okay, something is screwy here. Didn't I just... I had this at 0.75. Is there, does this need like a warm-up or something? Because you can also do this. This would be safer. But I think that this one might learn too slowly. And I'd really like to push this if I can. If we can get the mini batch to be, if stable, if training is like stable at this mini batch size, everything just gets faster. Oh, there we are. So we should probably do a couple runs of this since there's going to be some variance, right? But just doubling the learning rate seems to do most of what you'd want. Yeah, there is a little bit of variance though as to like when it solves. Because this is now on par with the previous learning rate curve. I would still expect I would still kind of want this to be default though. If we don't push the learning rate too high, the larger mini batch should be stable, and it should help more on complex ends. The data gets less off policy. There are like a lot of benefits to this. Yeah, so it's somewhere in this window. Somewhere in this window. It should full solve if I just give it 100 mil, right? It's like 25 mil frames. This dip in the curve also right here, this is kind of a cool artifact in RL. This is where it clears the first screen of bricks. So like it has to learn to hit the last brick reliably because it's kind of hard to hit. So like you actually get learn curves in RL that sometimes reflect specific difficulties in the environment. Okay, so there we go. This one that's a full solve. That's good. $32 seconds. I don't really think we need that. I think we can just leave it on this. We can always double them for the demos, right? We can just train twice as long for the demos. This is like still pretty good. Okay, we'll just use whatever the first one was. This one's old. Play here. We'll be fair in our evals. Let's just remove all these. That. There we are. So we've got our 29 second, 26 second now, 3 mil training, 3 mil step per second run. And we've got this run, which is actually fairly close. But a little slower. A little slow overall. And then the training speed is like half. Okay, so next we're going to see if we can do the same thing on Pong. I'm just going to go through all the M's and see if we can get ludicrously fast training with the new infra. So Pong should be comparable, maybe slower. I think slower actually training because the number of M's. This one might be a little difficult, come to think of it, because it's like only 20 mil total steps. So this might be tough to match. What I was going to do first, if I just... I'm pretty sure this makes it worse. We'll see. It'll make it fast. So yeah, immediately this is now 3 times the speed. And I haven't even fixed training yet. Yeah, but we only get a score of 17. Let's try if I do this. What happens when I do this? This should go over 3 million. It's 4 million step per second training. Okay, there. Yeah, but see, it it doesn't like train well. Let's see if this one happens to be stable with higher LR. I'm just curious. This is not even with a trivial model is the cool thing. Like this could be even substantially faster with without the LSTM on it. So this is actually the training speed with like a reasonable model. Little MLP into LSTM, not just like a 2-layer MLP or something dumb. We might have to change the eval intervals though. This takes forever to evaluate. I don't know why it's like getting this many data points. Okay, so it actually, interestingly, it didn't do really any better, but it also didn't do worse. If I just up this to 40, it'll still be faster. Where's info? Why? Wait, why is there no info coming back from this? Oh, this is the wrong one. Tick percent log interval. So this is 128 times 4,000, 80. It's just not getting logs back. That should be getting logs back though. I guess like the games just take a long time to finish. Evaluated 100 million steps. Okay, we're gonna have to mess with the eval stuff today. So like what's going on with this? That it's not something screwy. Vec log. I can't see anywhere where you'd be dropping logs. Right, where you'd be throwing away logs. Unless I'm doing it by mistake in clean PufferLib. Yeah, so you wait for... This should be totally fine. Let's see if it's just a sample thing. Oops, wrong one. Like, does this thing eventually log? I 8x to the number of environments. I should still be getting logs. There we are. Oh, and then I get consistent. So it doesn't even finish the episode, I guess, what happened. Okay. $274 is the episode length. And it's not training stably. Or something. No, it is. Oh, you know what this is? 74 times. I mean, there's only 2 million. Hang on. There are 8192 total M's. And it's only 274 episode length? No, but the 274 episode length can't be right. That's really short for Pong. And it jumps up to 20 score. So basically, it's like, I think what's happening is the games are really long. So you don't actually get to see the good policy during training because it's literally just playing one game. But then it just knows how to play the game perfectly. Which would then actually imply that you need to reset the environment. Yeah, so that's a perfect solve. Okay. But the logging is just not going to be great for Pong because the games are really long. Okay. But the eval at the end should be accurate, maybe? I might have to reset the end. Hey, can you reset the env after it's... I think you can. Make, and then... When does it get called and reset? Is it... I'm just concerned here. Basically, the thing I'm worried about is if the episodes are really long, it might, like, during evaluation, not run new games. It might just be finishing all the games from stale policies. So I think that you gotta have a reset in there. Okay, so this is now 17. And presumably is not stable if I do this. You know, the other thing I'm realizing is we could retune. We could not go crazy with this. Yeah, so this isn't stable. But if I do like 80, it's probably good. So what we could do is we could retune breakout, right? For the high batch size. That's probably going to give us some different optimal hypers. And then we could apply those across everything. They're literally 30-second runs. We could probably do that live, couldn't we? Why don't I just set that up right now? Okay, so yeah, this solves an 80. So atom epsilon, atom beta. I believe 64 is max BPT horizon, right? 8192. Yeah, so 64 is going to be max. Gradient norm, value function. We don't really need to tune update epochs, right? Tuning in, did you do anything with impulse? Not yet, Captain. What I'm currently trying to do is I'm trying to see if I can get stable large mini batch training, which should help all of us on everything. Okay, so that's now just tuning like the standard stuff. And yeah. Did I forget anything else? Why do larger? It's they're faster to train. Do you see this 4 million step per second Pong? It's not speaking of that. That's with a real policy as well. We can make it substantially faster than that with like a silly 2-layer MLP. So unless kernel gen messes us up, we should. This is the crazy thing. We should literally be able to do a breakout sweep live. Why did it just train for 50 mil steps? Oh, because the sweep. Hang on. Yeah, we don't want that. We want 80 mil. We should literally be able to do a hyperparam sweep live because the runs are 30 seconds. Eval might be a little annoying, we'll see. But yeah, 30-second breakout runs is kind of nuts. I'd be interested to see how larger mini batches do in impulse wars. I did 3 or so sweeps. Protein never seemed to want to explore it. Didn't find good runs. Yeah, so previously, right, here's the thing with larger mini batch size. You get fewer gradient updates. So you need to be able to actually make large, stable updates for it to be useful. And what it seems to me is that because of all the new algorithm improvements we've made, it seems substantially easier to do that than it was before. Muon and such are more sample. It's not necessarily that it's more sample efficient, it's that it's more stable. So it means that like I can push the learning rate higher. So I can make larger gradient updates than I could with Atom. That's what it seems. It's weird how like the first few experiments really aren't finding very much, huh? It's still training past the allotted time step budget, actually, isn't it? I'm not sweeping total time steps, at least I shouldn't be. What the heck is it doing? Yeah. The hell? It's just doing what it wants, I guess. That seems like a bug. You know what? I don't know why it's doing that, but we'll let it cook a bit. We'll see what it figures out. Because it actually seems like it got a lot of information out of that run, right? Because now all of a sudden it's got like a reasonable, like it got more reasonable perf much faster. It should be recording 10 data points for each of these runs as well, so it actually should learn from the whole curve. And just let Muon do its thing, and Protein do its thing. I do want to figure out what the heck it is that's causing that bug in the meantime. Oh, is this it here? Oh, yeah, this is the bug. It just keeps going up and up in total time steps. Yeah, we gotta fix that. There's the bug. When I increase the mini batch. Yeah, that's not a good thing to do, really. So there is like a log failure thing. I gotta come up with a better way of doing this, though. Well, now, at least now we know why that was happening. It was just gonna keep running longer and longer experiments. Yes, we could technically do that, but I don't know if I want to. The other option would just be to, like, correctly constrain the search space. You know, I could do something like you add constraints like x param not bigger than y param or whatever. Okay, this seems like it's already way better. Yeah, this is already way better. Hyperparam tuning in real time. We also might want to do runs and child processes. I generally don't like kicking stuff into sub-processes when I can avoid it. Because you end up eating error messages and stuff. I would think that the better solution here would be to just constrain the search space more correctly. And, like, we could add more stuff into protein to help with that. Like, there are not that many, like, you can't out of memory yourself by increasing the learning rate or something. It's literally just, like, batch size, mini batch size. Maybe BPT horizon. Yeah, it's a little tricky to like detect if max batch size can OOM. Um, I guess now with like variable net sizes, you can also do that, which is a little janky. I want to think about it. I don't want to just like throw everything into a subprocess by default. That seems like a bad hack. Because that literally makes all of the errors more annoying now because now you get like stuff obscured by being in a subprocess and eating traces and whatever. Can we just bring up the fact real quick that while we've been having this conversation, we've done nearly 1 billion steps worth of sweep experiments. You can just set standard out and air to parents, and that's not really the issue. You do screw yourself from being able to set a breakpoint on error, right? Like right now, this is actually one of the things I was really proud about with the new sweep system, is because we don't have Wanby's thing that like throws it into a thread or whatever. You can like set conditional breakpoints or whatever in a sweep and you will hit them. And you can just debug. Three million steps per second training is about 10 billion steps per hour. 10 billion steps per hour is wild. This is on the 4090 as well, not even the 5090. This is just on my local machine. I mean, I agree with the problem that you brought up of like sweep should be stable and not just crash due to OOM. I don't necessarily like these proposed solutions. I think you would get like 80% of the way there. So the place where it's most likely gonna OOM is on it's the train step, right? Like the backwards, like you have to do forwards backwards on a mini batch of like 32K or whatever. I could probably just dynamically adjust gradient accumulation based on your network size and get like 90% of the way there, Captain. So there's when you do the training step, right, there's a maximum mini batch size. That's the most memory intensive thing in Puffer, like by a mile, because that's you have to have you're doing a forward pass over 32K samples or whatever, say, if you have a big mini batch, and you have to keep around all the activations to do the backwards pass, plus like all optimizer state stuff. So, but I have gradient accumulation where you can split that mini batch into a smaller number of mini batches and have the result be identical. And it's actually hardware efficient to do that with larger networks as well. I can probably just set that automatically, and that'll catch like 90% of OOMs. Oh, hello, Spencer. I have been sent a link. Interesting. This one looks pretty good. These curves are a little wacky. But interesting. Split mini, something like that, yeah. I wouldn't do it based on VRAM. I would just do like a rough thing based on network size and catch most of them. Orange one's not bad. This is only 250 mil steps as well. How are we doing on our sweep here? Oh, we're getting somewhere. We're getting somewhere. I kind of expected this to find good hypers a lot quicker, considering that the defaults were so good. Let me make sure I didn't mess anything up in the configs for this. Mess something up. I don't think so. It probably just takes a while to sweep over all the stuff. A lot of hyperparams. We are not even sweeping any of these priority replay things yet either. That should be able to make it a lot better, maybe. Let's see what it's doing on sample wise. Being pretty high learning rates. I should probably have this. I don't think there is actually a way for me to like log the Pareto front correctly. Value coefficient. Norm. And we have a couple runs in here right now that are decent. Yeah, there are a couple decent runs here. Wait, if these are at... Did these just get run? We didn't have these a second ago, did we? Oh no, we did. Yeah, we did. Perf is just a normalized score. It's the same as if I do this. Same exact curve, changes the axis to be whatever the M specific metric scale is. I wanted all the M's to have a perf so that like we can benchmark all the different M's and put them on the same plot and get like an average or whatever. So I added that to everything. For Impulse Wars, it would just be like the win rate or whatever. You would just log a 1 for a win and a 0 for a loss. Yeah, that's what you would do. Or perf, yeah. I can't call it score because some environments actually like have a score, right? So that needs to be called score. So I made this perf just like a normalized thing. And you can't even call it like normalized score because like Enduro has a score that you could normalize, but that's not actually the metric that you would like to log. So it's a little silly. So that was at probably too high learning rate and crashing. I'm trying to think what protein actually does when you have the same cost everywhere. It should still work, but I gotta like there's some cases to analyze. This is pretty good. Oh, I thought I had yeah, if you zoom out, we have 6 here as the best, right? Close to 6. Right, what is going on with our breakout sweep? Why is this thing having such a hard time finding good parameters? Like some of these runs are pretty reasonable. Okay, we are making some progress. We are starting to get some better runs. Okay. My hope here was that it would be pretty easy to like retune this thing. Do we have any predictions here, like what should change? Maybe like gradient clipping and stuff should change. We actually haven't swept that lately at all either. You kind of have to do that again. So we'll give this a few more runs to see if it finds anything, because these are starting to get better. And then I think what I'll do is I'll just take whatever I have from that. I'll throw like some fast version on any of the M's where I can get it to like remotely work. And then from there, we can do like a more full sweep, or we can start like doing some more full sweeps on all the new parameters and stuff to see if we can really optimize. And then we test on the harder M's like neural MMO to see if they actually, the stuff that we find on the simpler M's actually holds up. That's going to be the play. We just got a good run as well, didn't we? Yeah, so we are making progress here. This is a pretty interesting gap here, this like train to eval. This means that the actual length of a game is pretty long, like, maybe a game lasts this long or whatever, so you have an old policy at the start of the game and you lose a few lives or something on it. Would be my guess. This is a big eval gap from here to here, like vertically. So here, this is what I was looking at, right? So 0079, it is trying to find higher learning rates that are stable, it looks like. It's very difficult to get this to be stable, but if it can find other hypers that help this be stable, then you would expect a learning rate around here based on the batch size. Also, gamma is not going as ludicrously high as it was before. There is actually a fair bit of shift, I think, in what I'm seeing here so far, compared to what we had before. Entropy being this low is a little weird. And here is the Pareto front. I guess, is this going to just be from BPT Horizon? No, because it's mostly these. So this is just like run-to-run variance. 10-20% run-to-run just variance. A little wild. You start looking at some of the other M's. Snake is one where we were able to get it to go like really fast. Hey, what are you up to today? Hey, Cash. So we got yesterday, we kind of realized that we're starting to get to the point where we can use larger batch sizes, larger mini batch sizes, and have training still be stable. So we're seeing if we can get some of the simpler M baselines to now be training at like 2 to 4 million steps per second instead of 0 to 1 million. So now this is kind of cool. We're sweeping breakout. I'm literally doing this sweep live because the runs are 30 seconds each. It's doing like 10 billion steps of training per hour. It's pretty crazy. And actually, there's still like 25% overhead just on copying data to GPU here. This could actually be made a fair bit faster even, potentially. Now, the only annoying thing here is I think that the perf improvements aren't going to be as significant for larger networks, but it is still important for us to bring up the experiment speed on these smaller ones. And I think that you're still going to be able to use the same like batch sizes and stuff on the larger nets, and it should still be nice and stable. It probably just won't have the same like wall clock perf improvement. But you would actually expect larger batch sizes to be good on more complex ends anyways. So this is generally like a reasonable direction to go. Did I like totally mess something up, or like why don't we have a full solve here? We had a full solve with the original hypers. I was just trying to do better than that. Huh. Possibly just needs a really big sweep, I don't know. I say we give this 50 experiments and then we call it. Unless this does something wild in the next couple of experiments. We'll take this part of the work offline, and we'll just see if we can get current hypers to do something reasonable, and then we'll expect that if we run a much larger sweep, that we should be able to do better potentially than this. Because we know that there are better hyperparameters in the space than this. It's just about running a long enough sweep to find them. Possibly messing with the defaults as well. Okay. So, nothing really amazing with this. But this is your sweep. This is 50 experiments. We just did this live. 50 experiments is that 4 billion steps of data? 3.2 billion steps of data. Cool. So I believe we had Pong running, right? Weird Pong curve. Does solve though. You're just doing this wrong. Okay, so this is slow baseline. That is not good either. Hang on, I'm messing up a ton of stuff up here. Let me just stop being sloppy. Okay, now this should work correctly. And we should be able to crank some experiments real quick. And we put this on fast baseline and we see that it's fast. Okay, that's not bad. So we have fast baseline, which does this. Kind of screwy. Why is... Oh, because it ran a ton of eval, I guess. Sure. There we go. Ran a ton of evals. Here's the snake slow baseline. Snake was a fast end though, right? Shouldn't be any faster than Pong though. So maybe it gets like 3-4 mil optimized. 94, very good. So this is a very strong baseline for snake. And then we will do this for the fast one. And then this is num m's is 8. So 8 times 256 is only 2048, so we go to 16 m's for the new baseline. $102. Yeah, this is a very strong. This has actually got better since we fixed some other stuff, like 100 plus on snake is kind of crazy. This will be a good end for actually, I think, for testing the larger batches. You do sort of need stable updates on this. That's going to be hard to beat, though. Curious to open the curve on this. So it's pretty flat. It wiggles around here a little bit. It does seem like it goes up slowly. 105. So I guess the bug fixes I applied actually helped, because this is higher than it was before by a couple points. A few more than a couple points. It's significant. I think it was like 100 or something before. Now we're easily above hundreds. Yeah, that's a very good result for snake. At least this is giving me, I mean, the one thing that this is doing, and the reason, part of the reason I do stuff like this, where I kind of just slowly manually run experiments, this is giving me a lot of confidence in the new dev branch as being like a stable, high quality improvement. Like this is a solid learn curve for snake. Snake is usually very hard to get like above this initial increment here. It's usually quite difficult to do better. So, I mean, this is like a tiny network, right, that is being trained for 300 mil, and the tiny network is continuing to improve. Okay, so 3 minutes. Pretty good. Now we run this one. Be fast. The number of Twitch bots is kind of ridiculous. Only 2.4 mil. I messed something up. I would have expected more than that. $40.96 M's. I didn't mess anything up. Num snakes 256. Be 40.96 snakes. I guess this is the conf policy. This is still a faster than I've ever had snake going on this, I believe, so it's still good. And how are we doing on our run? 105. So we got up to like 108 or whatever. So this is match. So this is just free performance. It just works on Snake. Can't complain. 110. No compromises, just wins. Perfect. Favorite classes you took at MIT during grad years? I mean, not a single class was remotely relevant or useful to anything that I do now, frankly. You only take 4 core classes, um, like required classes. I took some business electives that were good. Um, Let me think. Oh, the one course that was very good, though in no way directly useful to what I do, I took Sipser's theory course, like his intro, whatever it is, theory of computation course. So that was kind of cool, because I really had not done much proof-based math at all, outside of like the Stanford undergrad requirements. Um, and like I actually had time to do it properly. So it was like, oh, okay, I see proof-based math, like I could learn this if I put in time. Like, I understand how this works. Cool. If it says theory of computation, then yeah. But like, I took the NLP course, wasn't useful. I mean, I took my advisor's course, which is not by any means a bad course, but like, you know, hopefully if you're there as a PhD student, you already know all the material if it's in your domain, right? Um, and then I took a deep learning hardware course that was like kind of interesting, and like, yeah, learning about like matrix multiply tiling and stuff was good. But they used a bunch of kind of janky like performance monitoring tooling and stuff. I mean, that's what everyone takes. I don't know if are you a grad student or an undergrad? Undergrad? Fair enough. I mean, I did my undergrad. My undergrad was Stanford. Um, I don't think any of the universities have like a lot of good courses, frankly. There were a few good ones. Like my undergrad course is Stanford. So the the data, like the initial data structures and algorithms course there, 106X was like okay. 103 was really good. It's like complete newbie intro to um I guess proof-based mathematics as it applies to CS and like discrete stuff. Um but it's like really well taught. Keith is awesome. I hated the system courses there. Actually, that's probably the thing I'm most annoyed about is it put me off of doing low-level programming for 10 years. They were that bad. And now I love low-level programming. Um, Jerry Kane's done like impressive stuff, but he's just a terrible lecturer. He's really, really bad at communicating stuff, and the problem sets were just abysmal. 161 was their like, was it the advanced undergrad? It's not that great. Their intro stats is good. Um, the best like grad course there was 231N. I think, yeah, Stanford's deep learning course is still better than MIT's. Um, yeah, I don't know. I would imagine that probably like other engineering disciplines at MIT have cool stuff, but there wasn't much in CS that I know of specifically. The one thing that was kind of cool was I don't know if you can do this. I think you actually can as an undergrad just go enroll in Sloan courses. The business law course was very good. I think that one is pretty darn useful. for doing a startup. It's basically like how to not accidentally land yourself in jail when you're just like a tech guy trying to make stuff. So that was cool. Um, yeah. And if you just want a major confidence boost, go like take one of the startup courses there and see like the types of people that are doing startups without having a technical background. And like you'd be like, oh, I should just do my own thing now because if this is my competition, I should just do my own stuff. So yeah, that's the summary. I wasn't much on courses. I just generally do not enjoy doing courses at all. I spent the vast majority of my time in grad and undergrad on research, but there were a few good things. And there you go. There's your probably more than you needed in-depth summary. hmm Honestly, like the main thing that's tricky that you got to figure out is you got to figure out how to like to spend time in undergrad like on projects that actually teach you stuff. That's the tough thing, right? Whether it's research or open source or other things around there. I suggest PufferLib. Of course, I'm a little biased, but if you want to hack on cool RL stuff and not deal with ludicrously deep software stacks that make no sense and learn low-level programming stuff as well, you kind of can't beat it. Oh yeah, I actually have a question for you because I didn't really talk to many undergrads at MIT. Is undergrad at MIT any fun? My impression is like as an undergrad at Stanford is that Stanford is a lot more fun as an undergrad. Yes and no. I mean like I think MIT just hammers you with technical coursework a lot more. Like I had like 90-hour weeks average, I think, my freshman year at Stanford, but that's because I did the whole core my first year. Stayed up all night laying out a chip. That's kind of cool. I don't know. My impression was that like kind of regardless of what you do, you're going to be ludicrously busy at MIT. And the Stanford was more like a choose your own adventure. So like, yeah, if you're gonna do the whole core your first year, you're gonna be busy. But like, most people really aren't that busy there. No, no, no. It's kind of a funny question. It's like, do you have any fun? I mean, being incredibly frank here, right? I did a ton of just like incredibly stupid stuff as an undergrad. Um, I didn't touch anything but alcohol, so I reserved that. But I just did a ton of incredibly stupid stuff, and like I don't necessarily regret as much because having been incredibly straight laced everywhere through my whole life leading up to that, I think I'd feel like I'd missed out if I hadn't. So undergrad is kind of a time to get that good time to get that out of your system, but at the same time, it's also a good time to like learn a bunch of stuff and get really good at what you do. So there's a balance. You can min-max, basically take the minimum to graduate and be under 40 hours a week. That's not bad at all. Too many classes I want to take. If you like taking classes, then sure. From the ones I took, many of them just weren't useful to me. Like 15 hours a week working on a side project would be more valuable than a lot of the courses. And that was true of both. I think that's true anywhere. Okay, so we have this one, and now we will compare to, oops, to this. See ya, and best of luck. Thanks for dropping by. I'd say I have dramatically more fun now, though, than I did in undergrad, with a few exceptions. Maybe not. I think I have less fun, but I'm much happier overall. I don't know. Alright, we're getting some training here. This is looking reasonable. So we're at 0.1. Likely will be less sample efficient here, right? Maybe. Max enjoyment is lower, min is much higher. Probably, yeah. I don't know. Last year kind of just absolutely sucked. And then this year, I started the year by nearly dying of pneumonia. So, but since then, it's been pretty good. I've just been enjoying getting myself back into good shape, and I've just been cranking out work on Puffer. It's also, I think it's having it be part of the business is like, part of a business is really nice because it doesn't really feel like I'm just in a hole anymore, like working on stuff that like, you don't like, the most you get out of anything in academia is maybe you get some recognition or whatever. But now it's like the recognition comes in the form of people DMing me for like for jobs, right? And like interested like clients, people wanting to hire Puffer for stuff. So it's cool. It's definitely cool. Okay, 0.24, 0.2. This is good. 2.3. This is a solid perf. What else do we do? I kind of want to try something harder. I thought I did something with it. Hang on. It's going to get way better, I think, as well, with all the stuff we're building lately. I'm definitely working harder now, though, than I did during the vast majority of my PhD. But I'm less burnt out from it. Like, the work is better. And, like, also, I don't have as many ludicrously arbitrary deadlines. So, like, it's like, go, 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 get the thing done, get the thing done, get the thing done. But if it's like, hey, I just can't do stuff today, I just need to recharge, like, I can do that as well. That's pretty good. Welcome, YouTube folks. For anyone new here, this is live reinforcement learning dev. At the moment, this is running a whole bunch of experiments with much faster configurations to see if with all the new, algorithm improvements we've made lately, if we can get away with larger batch sizes, mini batch sizes, and larger learning rates, and seeing if we can actually like get reinforcement learning an average of 2 million steps per second instead of 1 million on a dozen different environments. Okay, so Spencer's env, we get 90 with his defaults. And then it crashes a little bit here. Mostly 90. That could be the cosine. No, it's not cosine annealing. He has learning rate off. So I'm just going to delete all his hypers and see if it makes a difference. No discredit to the folks who did the hyperparam tuning. I did hyperparameter tuning for each and every individual env like 200 runs before, but we've made algorithmic improvements, and things are generally much more robust now. So you can almost use the same hypers for everything, almost. I believe we might have to keep gamma at like 0.98 or something, we will see. This is just not evaling. Do this. Interesting. Okay, this is running. I'm gonna use the restroom real quick. I'll be back, and then we'll keep on this for a few. How's this looking? 85. So, it's a bit lower. It's a bit lower. I do want to run one additional experiment on this, though, before we make any proclamations, because I do expect that this is probably just gamma being off. Let me just try this. I'd like to get tower climb with a good baseline. This is a really good env. Has configurable difficulty. Generally good time. This is a 560K per AM model, so we may have to reduce learning rate a little bit, we'll see. Oh, there you go, look, there's the perf. Ha. Easy. It's just that easy. Alright. Well, we can then absolutely use these. Do I want to try this learning rate this high? I guess we'll see if this crashes. I expect that there's a decent chance this crashes. Try it on hard, that'll come next. Let me get the, let me see if we get the fast params first. So we will get rid of this one, we'll keep the other one as the slow baseline. Yeah, this is good. So if this crashes back down, it's because the learning rate's too high. But that seems like stable 0.95 to me. We crashing back? No, okay. Cool. Hey, Bet, what are we doing? Leroy Jenkins? Well, we're always fixing RL. Okay, so I mean, we're pretty happy with this, right? This is a million steps per second on like substantially larger model. I think we're pretty happy with that. So I think we call this one here, but this works fine. What M's haven't I done? There are a lot of them, right? Jeez. Well, best of luck with that, Bet. And congratulations once again. What are you up to today? We're trying to get, well, It's better to just show you, actually. How's this? $3 million step per second training, 10 billion an hour. I think it's pretty decent, right? How did you fasterize it? You just retuned the learning rate a little bit. I haven't even retuned everything. Wonder why copy overhead is so high. I can do something about that. I should be able to get it to 0, Captain, but not yet. Oh, this is interesting. I guess it's not a multiple of 8. Work? What idea do you have for that? Would be huge to remove. We can asynchronously queue up data transfers, I'm pretty sure. But it's like a pain in the ass to do it in the multiprocessing implementation. It'll be a lot easier with a threaded implementation. Okay, that doesn't work. That's kind of weird. Oh. I'm just I'm fiddling with some batch size params to like make stuff fit. I'm gonna get like warnings on. I'm gonna put warnings on all this stuff, obviously, before the release. Can you check Discord? There you go. I've got a meeting about the professional thing that we discussed. We're gonna do Friday, so hopefully we get something going for next week. I was trying to set that up for earlier this week, but the guy I need to talk to about that has been slammed with work. So also they're still trying to figure out specifics. There you go. Box 6 is good? Okay. So I think I'm not going to ship any of the boxes to main gear then. I think I'm just going to like ship them direct to the new facility today. Some of them. So yeah, guys, get your work off the boxes, or like not off, like make sure everything is synced, because I'm just going to like grab them and start shipping stuff. I don't know how many I want to ship initially, and like we're going to have to figure that stuff out. But like technically, as long as there's internet, it shouldn't be that bad, right? Like worst case, I can just plug them into various different outlets, even if our main electrical isn't working. Synced, cool. I also think I'm going to take both of my desktops with me, just so like we have one extra and like I don't have to monopolize as many boxes. Why is this 41,000 SPS? Oh, because CPU trained up. I have arrangements bet. I thought I had fixed this. Yeah, well, we're not doing that, but I've got arrangements. I also have all the original boxes and packing material that they were shipped to me in, so for this exact purpose. Does this not work here? This new one's very nice, though. I will say this new one that I have, it's like very nice. It's like way quieter. Yeah, it's way quieter. Um, doesn't really like the cooling in it's very good. Like there are fewer parts that can go wrong. It's got higher quality fans. Oh, I didn't think about this, did I? Does the thread count have to be a multiple of the block size? Is that a thing? Like surely it doesn't have to be a multiple of the. Like surely you can have non-power of two matrices, right? Or non-multiple 128. Apparently not. Okay, I had not considered this. Is there anything I can do about this for now to fix this? None of these are going to be a multiple of 5. I could do slightly larger, or I could do substantially smaller. Like this, 2560. What if I did that? That's actually perfect. For now, we just do, so we want 2560 Ms. No, we want times 2. So we actually want 5120 divided by 8 is 640. So we want 128 Ms. I think this works. Oh, and then we actually, hang on. 128 times 5 agents per N times 8 is this. So now this is going to be 32, 7, 680. And this is like, we're getting some weird numbers here, but I just want to see if I can get something to run. We're gonna have to figure out the like non-power of 2Ms thing with the new CUDA kernels, but for now, this should be reasonable. Remove this cache. Did I not do this right? 128 times 5. It should be 128 times 5 times 4, 2560. I just want to see this end going fast. Like this one is, PufferLib is actually a pretty small setup. Wait, threads per block, 2 blocks, num steps plus threads per block minus 1. How did it get 2 blocks? That's definitely gonna fail. But why 320 steps? I'm quite confused. There's a second one of these, right? Oh, it's right here. So why is this batch weird? $320 by 64. Oh, that's not a multiple of 128. Yeah, because the mini batch needs to be. Dang it. And that's annoying. I could do the PPT horizon, not a multiple of 2 instead. $80. I think if I do 80, maybe this works. This is all just because CUDA kernels are not currently are kind of fiddly at the moment. Total agents. But then the batch size gets messed up. 128 M's, 8 copies, 5 agents each, 80 steps. Okay, this looks like these are all nice numbers. Perfect, 1 block. And now that works. So this is not going to be optimal by any means. But I want to see if this actually does what we hope it does. A network this size should be able to be trained quite fast. Definitely over 1 million. I don't think we've ever gotten this one to be fast. %45 env time. The M should not be that slow. I will have to go look at that, but env bottlenecked, otherwise we should be able to get something decent at least. This one will return stats, just it takes a while, the games are really long. There you go. So I'll be happy with this for now if it does train reasonably. It just won a game. There we go. Now it's winning games. This is win rate versus scripted opponents. And there you go, that's 1 win rate. We need to get some better opponents for this because this is a really cool end. Alright. This works. Trains 500k-ish. And env needs to be optimized, but this is all set. So here's what I'm going to do. I'm going to go get some exercise, get some food. I'm going to come back in the afternoon, continue finishing all of these envs up, have nice, clean, fast configs. I will be back on stream for that. And then tomorrow I'm traveling to the new facility. So I've got to take all my stuff over there. We're waiting on delivery of all sorts of new setup for the stream. And yeah, once that is set up, hopefully starting next week, I'll be live from there, assuming that everything's good with the internet and electrical and all that. So for folks watching, thanks for tuning in. If you're interested in all this stuff, it's all at puffer.ai, it's all open source. You can help me out for free by starting the repo on GitHub. If you'd like to get involved with dev, whether you have an RL background or not, join the Discord. Most of our top contributors came in with 0 RL knowledge. And other than that, you can follow me on X for more occasional RL content. I post some articles there that you